Welcome everyone. As construction costs escalate, codes increase, and skilled trades become harder to find, how can we build walls to achieve our stronger codes and meet net zero that are fast and work with available labor? We need to come up with new strategies to overcome these multi-pronged challenges that we now face. So let's talk all about net zero ready, durable panelized wall systems. Now, before we get started, I want to say a thanks to our supporting sponsor, Tamarack. Tamarack offers a wide variety of home energy savings devices and ventilation systems. They have attic access hatch, air sealing products, fire blockers to prevent air leakage, door and vent return air pathways to ensure good airflow. They have whole house fans to keep you cool while saving energy. And as a bonus, they're connected with our sponsor, Panasonic, that has all-in-one ventilation systems from exhaust supply only to full-blown energy recovery ventilation and demand-controlled ventilation. So check them out over at tamtech.com. All right, well, welcome everyone. Again, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team. My name is Brett Little, and I am the education manager here as your moderator today. This course has been submitted for multiple continuing education units and is actually approved for our Certified Green Home Professional designation under two pillars, energy and materials. Submitted for AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license, as well as submitted for Passive House Continuing Ed. So check, there will be a code that will be sent to you upon approval within your certificates if you've been here for the entire CU approved hour. All right, well, with that, I want to welcome back our speaker here, Brian Iverson, who's been on the show quite a few times, and he was actually part of our original residential net zero energy conference that was in person as well. So, Brian, thanks for coming back on. Welcome back to the show, and please go ahead and take it away.
You're dating me a little bit there. Oh my goodness. All right. Building net zero energy ready, affordable homes in 28 days or less. All of that is a mouthful. I should have just started out 28 days or less. I'm going to show you how we did it, and 40 houses worth, because I was the grunt on the job. And oh, by the way, we'll make them net zero energy ready because we now know how to do that. Okay, so this is a fast, jam-packed, as I say, might be a little bit Fargo speak session, and I'm going to try to go as fast as I possibly can. I'm Brian Iverson. I'm the founder of Envirobond. I'm the one who invented all the thermal studs products themselves, T-stud, warm stud, rhino stud, drain strip, and now the T-studs ultimate panel system. So we had to come up with the entire system that was deliverable, because we had to keep taking off days off the job in order to help some of the people that are around and reach out. We had to keep delivering a deliverable, and we couldn't get it there. We couldn't make the time go faster on the job, and so it just took a long time. It actually, the last pieces of the puzzle didn't come until December 15th. So you can read most of the panels. I'm not going to read the whole thing. I'm going to talk to you. So if people just get the panels, they're not going to get the dissertation. So you can read all that. I built 24 miles of roads, and my deepest manhole in the ground is 42 feet. So yes, I have a degree in civil engineering and architecture, and I've designed 750 places that have been built. The smallest one so far is 576 square feet, a one-bedroom house in Costa Rica. Okay, I'm a building science advocate. I don't put my hand up and say I'm a building science guy. So you can read the stuff on the right. I'm going to tell you about the photo on the left. The photo on the left is a legitimate, real job. It's 20 degrees on the outside. And obviously they're trying to warm up the inside of this house to 70 so that they can finish. This is a thermally broken stud here, and the bottom plate is not thermally broken. But what's interesting is that on the outside of this whole entire structure, this is where thermal imaging cameras come in. On the whole outside of this is an R10 rigid insulation. And that doggone cold was still coming through that bottom plate like a hot knife through butter. These are important decisions to be able to make. If you're trying to meet net zero, you can always buy net zero. You can put up a bigger solar field, wind, and do geo. You can buy yourself there, but how close can you actually get before you have to install those other systems? Whoops, wrong way. Okay, this is the question. If it's not built right, and with all the control layers integrated and functioning, when you're not achieving net zero, you're just buying net zero through the oversized equipment and add-ons of solar, geo, or wind, or whatever it ends up happening to be. So I like solar panels. I have a friend who has 6 houses in Canada completely off the grid, all running off of solar. So I know that solar can work even if it gets a little snow. Okay, what this means, it's the entire envelope. You can't leave anything out. You have to check every box. You got to check the floor, the foundation. You got to check everything. You got to check the wall, and you got to check the roof. So why do we start with the wall? Well, that's because Mother Nature is just trying to beat herself all the way through that wall. Hail, sleet, rain, wind, you name it, it's all going through the wall. The roof is made to shed the water, but the wall takes the brunt of all the energy. So you got to start with the wall, solve for the wall, and you got the rest of it solved. A true story from 1984, when I became a realtor. So I'm old. I'm going to be 65 this year. So send me a birthday card. When 1984, my very first real estate transaction was a $50,000 purchase price. The interest rates, the seller paid 13 points to buy the interest rate down so the buyer could qualify at 13% interest. This was how I got into real estate. I sold 50 houses the first year, but I have a long background in construction. I have a lot of people follow me even back then. So 1977, so I'm going to give you a history lesson of where we're at in 1977. So this subdivision that you're looking at here is legit. It's real. I've sold a few of these houses in my real estate career. I haven't been a realtor since 2006. And I hung up my license for good in 2010 after the pandemic. I represented a bank, and unfortunately, I foreclosed on 3,000 properties and sold 1,000 of them through 13 real estate companies. Couldn't save the bank. But this thing right here, we built this out in over an entire 3-month summertime. All stick frame, all block, all the whole 9 yards, start to finish. Okay, so the 28-day build original story. The contractor couldn't finance each home individually, so he had to create a system. This guy did this. It was him, one assistant, and one job site foreman. That's it. That's all they had. So all of the houses were pre-sold under FMHA, every single one of them, before he could even start. The lock loan limit was 60 days, and they were hard deadlines because the interest rates were fluctuating, sometimes 3, 4, or 5 times a day, just out of control. The closings were scheduled in advance. So what happened is on day one, he took out a little construction loan to get the lot in his name. He had to wait till noon for the documents to become recorded. Somebody at the recording office called up the guy in the job, said, "You guys can go on the lot." They excavated and poured the foundation in one day. The next day they started the block work, but on the third day, they were already starting to frame. So all the trades, all the vendors, every single person, everybody worked together. The plumbing, electrical, and the heating, they all worked at the same time. They all went room to room all the way around the house. Everybody had it figured out. Okay, we were the grunts on the job. They had to start the job in the summer when all of us got off. So we got off school on the very first day, and we had our first job site meeting. I was 17 years old. I had my first job site meeting, and I'm just a grunt. I'm just learning how to do sheetrock work. I guess I was pretty good back then because I ran the whole job. But anyway, 10 of us, we did everything, but we had to be done. They had to be done with the whole entire job by the time we all went back to school. This is legit. Now there's systems in place that can take roughly 10 days off this build. So what's our purpose? Our purpose is to deliverable, affordable, whatever that is, net zero energy ready homes. And you have to do that because people can't afford the fluctuations in the heating and cooling bills, especially on the electrical side for air conditioning. That's controllable utility bills. And at the same time, let's create a reduced carbon footprint. Let's create a big reduced carbon footprint. So we have a house, just to give you backup data. I got houses and buildings that I know of all over the country. But there's a house on the South Shore of Lake Superior. It's 2,500 square feet. Their utility bill is $45 a month. That's it. They heat the garage. They had an electric utility bill of $80 a month, and they offset that whole entire thing by a 20 by 12 solar panel on the south side. And as long as there's no snow over it, they have no electric bill at all. That's legitimate facts. Okay, I want you to dream with me, because this has taken a long time, all the way back Buzz Holtluer years. Seriously, best friend. Went to his funeral. 600 people showed up. There were 600 best friends. I thought I was the only one. Okay, we will not achieve affordable housing by continuing to build the way that we are. Well, we can still build the same way. We can build the same way. You just have to have a different deliverable system. You can actually build these panels right on the job. If you put 3 trailers together, you can build your own system and build them all on the doggone job. Well, that's kind of cool to think about, because you have no real estate overhead. I gave you something to think about. Okay. In fact, I'm not even sure what affordable means. Like, what's affordable? I see a lot of people are changing this to attainable. I know lots are a whole lot of money, and this is a whole nother subject. Maybe Brent will come back and invite me back once, as long as everybody says, yeah. Okay. I had a guy call up the other day. I got a guy. But once, this is the homeowner. They told me the general contractor fee. They actually showed me the whole thing. The general contractor fee was $115,000 on a $500,000 bill. And there's 2 sets of closing costs. This goes on all the time. I don't know who all is on the call, to be honest with you. Send me a message. But 2 sets of closing costs. We never did this in my entire career. We did a construction to perm loan right in the buyer's name, so we could flip out of it and be already automatically in the buyer's name. Buyer paid for all the monthly payments anyway. So we just stuck it all in the buyer's name in order to save money. I've done affordable housing all the way until 2005, a few thousand real estate transactions. So, but the 115,000 in this case, how can you make a deliverable system that you can actually set in an extremely short amount of time? How do you do that? Well, it takes lots of thinking and lots of people to come together in order to create that system. So how do we make it truly affordable and net zero at the same time, to have that occupants to have a stable, predictable utility bill? For the past 6 years, we've been working on this problem, not as a theorist, but as somebody who spent decades in the field. Literally spent decades in the field trying to figure this out. It's a utility problem. It's a construction timeline problem. It's a construction and a carbon reduction problem. And it's a housing equity problem. How do we get there? I don't have 100% of all the answers, and don't think that I have my crystal ball in front of me and I know every single thing, because I do not. We're going to build an affordable house, and Nick Lemmer and McCall, wherever he's at, they're going to help me set this whole entire house. We'll put it on in 1 day. We'll set it in 1 day. All the walls, all the roof, all set in 1 day. It'll be made for TV, I hope. Okay, so here happens to be a job by Jake. He'll set all these panels. I don't know, I haven't asked him, but I see he's online. And this would be, I'm going to assume, a 2-day job to set all these panels, 100% thermally broken, whole 9 yards. Next day, they'll put the roof on. So what if the roof system could be a complete drop-in place, passive ventilation, WRB ready, all dried in, all at the same time? Is that system available? Completely a drop-in. They're called cassettes. And the answer is yes. There's a lot of companies that do it. And but they don't have all the solutions attached to it. But if it could, you could literally set a house, all the walls and the roof in 1 day, and you could be putting the roof on the second day and set the windows the next day. That's how you have to dream. You have to have a target. You have to have a target. So what we're going to cover today, all 8 control layers. I'm going to go over all those, and this is a very short amount of time, and the ingredients. So I wrote a book about all these ingredients, and I don't care if you're net zero energy ready. I don't care if you're net zero, LEED certified, Energy Star, passive house, or all of the Canadian versions of all of that. The recipe is the same. You have to solve for all 8. Well, most people solve for 7 control layers. We just happen to have the 8th, which is passive. And so you have that. The ingredients are the same. You just have to figure out how to get there. So to build, we build futures. When we solve for energy and affordability, we don't just build homes, we build futures. There's a gal in Blaine, Minnesota, we sat down with the other day. Her monthly utility bill in an apartment is $300 a month. The door is undercut by a quarter of an inch. You can feel the gush of air coming flying through it. And her patio door is caca, and it's got a crack down at the bottom. In fact, there's so much air pressure going into this thing that you can't just open up the patio door. Why do we build that crappy? It's just an embarrassment. And unfortunately, I'm formerly from Minnesota. On the picture on the right, there's wood studs and there's metal studs. You have 100% complete thermal breakthrough on the whole entire outside of that assembly, and you have a partially filled cavity. And we had to do all of that in order to make sure that we got the racking strength of that whole entire assembly, metal or wood. Our goal was to get to 1,000 pounds per lineal foot, and we have succeeded that handily. So, okay, national reality check. 64% of Americans live paycheck to paycheck. 1 to 3 households, they'd have a hard time coming up with $400 to pay for an emergency, and they're happening more and more. Average age of people 55 and under, they only have $1,000 in their checkbook. This is reality. And they only have $100 today discretionary income. Back in 1984, those people had to go through their whole budget. In order to solve for that, they had $35 extra a month. That's all that they had. They had no extra money. So the path to net zero, energy ready, affordable, carbonless homes, in this order: we need to build smarter. We need to build them faster. We need to build them repeatable, and they have to have a deliverable. And why it matters: to lower those energy costs permanently, not just temporarily. You need to reduce them permanently. You need to reduce and stabilize the whole entire housing industry through smarter construction, but not a type of construction that, doggone it, builders are allergic to change. So you had to make it a standard way of doing construction. Otherwise, they were just going to put their blinders on and say, I'm not doing it. And you need to empower communities and not burden them. So a key insight: to solve for affordable housing, we unlock a deliverable building system that can meet net zero energy ready standards at scale. So this is not just for custom homes. See, if we focused on the affordable housing, you can always solve for custom. They can do it all the time. But if we started with all custom homes and then you tried to backdoor into the affordable side, I couldn't get there. So I just said, I'm going to go the other way around. I'm going to come in from the bottom up. So building science. So here's your how physics shapes net zero homes. This is Fourier's law. This isn't my law. This is Fourier's law. And heat flows from warm areas to cool areas at a rate determined by the material's thermal conductivity. So when you have a 2x4 or 2x6, a 2x4, the R value is 3.75, a 2x6, it's 6.8. But if your cavity insulation is 19, you can see how the R value of one greatly affects the R value of the next one, because you have conduction, convection, and radiation going on in the same wall assembly all at the same time. So how do you make that effective? Well, you make the wall assembly, studs and all have the same or as near to the same R value as the studs themselves. And you minimize the ability of convection, conduction, and radiation to go on in that wall assembly, because you don't have all those massive extremes of temperature fluctuations. Okay, so that's how I started this, and that's how I'll finish. It's making them effective. So that's Fourier's law. First law of thermodynamics: conservation and energy. Energy cannot be created or destroyed. It can only be converted from one form to another. So every watt of energy that you use must come from somewhere. It's solar, grid, or gas. So how close to net zero can we make? How energy efficient can we make the structure? And how little of energy do we have to have or create or use in order to be able to maintain our comfort for the occupant, whether they're in work, if this is the working environment or if this is the home? How do you make that envelope to be so energy efficient? And that's what we solved: a simple, affordable solution. And then obviously you don't want that thing to leak. So I wrote all about leaks. Entropy increases, the second law of physics, thermodynamics. Heat naturally flows from hot to cold. Every energy conservation loses some usable energy. That's a fact. But when you can build them this energy efficient, you can resize the HVAC system. You can make all sorts of changes, but you got to have a history of building this way. At the bottom, I just wrote it right out. You build tight, you insulate right, and you reduce the cycling time of the system itself. And that, so my favorite line in life is every action has a reaction. Sometimes you don't like the reaction. And in this case, when that system doesn't cycle, you have excess moisture that you have to deal with. So on the right-hand side over there, I buried the twin beam technology for barn dominiums. We have a wall coming up, it's 20 feet tall. It's a 2x4 and a 2x4. Look in the picture, the middle. I buried that little thing in a patent. And so we had a Hutterite community reach out for 26-foot tall walls the other day. And it's a 2x4 and a PSL stud, got 26-foot tall gymnasium, all net zero. Third law of thermodynamics. Absolute zero is unreachable. You cannot get there. I don't care if you're a Yeti cooler. And by the way, a Yeti cooler does not meet the energy code even in climate zone 0. And so it is not the do-all, end-all of solutions when they talk about Yeti coolers, but it keeps 50 blocks or 40 blocks of ice frozen for a week, and after that they don't last. So that's your how much energy does it take to keep it there. So I have lots of analogies. You can't go through life by being a building science advocate, analytical, and not have some humor. Why start with the wall assembly? Because the wall is the backbone of every building envelope. It's the first line of defense from Mother Nature. It's all structural. Structural. It holds up the floors and the roof. It resists heat flow. You got to block out water and moisture. You have to stop the uncontrolled air movement. You got to dampen the sound. So I'm a titanium member of, we'll talk about this. I'm a titanium member of Marriott. Only 2 times ever have I been intrigued by what went on in the room next to me. Okay, so I know you should see a whole bunch of laughing symbols coming up, and you got to control vapor diffusion. Oh, by the way, this is McCall Miller. McCall Miller is throwing up some test panels that he was doing, trying to get a pretty spray foam job here. We tried to perfect a pour foam and have $2 million invested into it and couldn't build a panel in less than 40 minutes. So now the guys and gals actually can build panels in 5 minutes. So this happens to be McCall. Don't look at his shoes. This is test panels. And what we do here is, because I've been onto lots and lots of jobs where I see the foam exposed, we try to cover up that foam. Usually in this case, it's a peel and stick WRB, but we're non-denominational. Every licensee is able to use whatever the client wants for the sheathing, water resistant barrier. We have the drain strip on the outside for passive cooling, but physics is not optional. All those laws in the past, you have to abide by them all in order to meet your meet whatever it is, certifications that you're trying to have. You have to meet them all. So here's your 8 control layers. Wrote them all out for you. 1 is structural control. You got to keep Mother Nature out. You got to hold up your roof. You got to hold up your floors. I got asked by the Canadian government if we had a stud that could hold up an 8-story building, and I said absolutely. And I said we can actually do the bottom floor at 24 inches on center because they're so strong, but we got to use LVL for plates. So they were intrigued. This is the Canadian government, and there's reasons why they reached out and asked. Number 2 is thermal control. So I did all these in order. Thermal control. You have to slow down or stop Mother Nature from coming through that wall, but you got to be affordable at the same time. So if Quentin Farrell was on the line from the UK, he was telling me once, he's a great friend of mine. He was telling me once that one of the systems that he saw has 28 solutions from the outboard cladding area to the inside, 28 parts to the assembly. That's not affordable. It is not. It's how do you deliver an affordable system that's attainable, affordable, duplicatable, the whole 9 yards. Acoustical control. This is for not just exterior walls. It's for party walls, party walls. Good grief. I already told my story. Vapor control. You got to minimize vapor. You got air control. ACH through a panel is zero. Literally air control. I'm old. 1982, we went from 2x4s to 2x6s in Minnesota, and we had to seal called Category 1 construction. We had to seal up the walls and the whole entire envelope, so energy efficient, airtight. But I was the guy running the caulking gun and the black acoustical caulk. Went through a pair of pants every day, and I couldn't find all the holes. We didn't have thermal imaging cameras back then, and we made our own redneck blower doors and tried to see where the leaks were. But we chased every stucco manufacturer out of Minnesota. I got to keep going. But moisture control, water control, that's the outside. And I want to talk about number 8 is ventilation control. I don't have a clock on. Somebody do this and tell me how many minutes I have. Eighth control layer is passive ventilation. Passive is free. It's called redneck air conditioning. And so when you build anything, if you're in the South, it's crazy to me in the South, the climate zone 0 to 4 today, 5 really, unless your state's adopted a higher energy code, you're still building with 2x4 walls. Well, that's because you're afraid of losing 2 inches on a floor space, and I know affordable housing. But what happens if it didn't have to cost any more money? What happens if you could deliver the solution that they needed to have in order to be able to afford the air conditioning to be on, say, 72 degrees instead of 78 degrees? So yes, we have a wall that's only 2.5 inches deep that's stronger than a 2x4, and it's made out of wood. If a wood could chuck wood. Okay, the 8th control layer is all about passive ventilation. When that sun hits your wall, it's going to heat up the studs on the inside, and that heat just transfers through. And I go back to the hot knife through butter. But if you do the ventilation control on the outside, I know it's rain screen part of it, but you got to have a lot of air. We're 96%. That air just flows right through. I know high pressure goes this way, low pressure goes this way. But if you run it across your roof, you get to cool off the doggone roof. So on the right here is this passive ventilation. You can see by the blue arrows how it actually runs in between there. And obviously you don't want to run that moist, damp air that's behind your cladding. You don't want to run that up into your attic space. Don't do that. And on the roof, depending upon, you can't do it on shingles, but you can, under metal or clay tile roofs, you can run that passive ventilation completely right underneath that roof. And just for fun, on the left, there's a thermal imaging camera. I happen to own a few of them because I want to prove the products work. We reduced the roof temperature by 19 degrees, just straight passive cooling. Free people, free at last. Okay, but this brings up the next thing. What's a low load building? A low load building is something that is so energy efficient that the HVAC system doesn't run very often. But back to it's every action has a reaction. Sometimes you don't like the reaction. What happens if it only runs for 5 minutes in an hour? Well, what do you do the rest of the time? I know that you got your walk out and you're cooking with your wok, right? You're taking a shower. We as human beings create moisture. So there has to be a moisture system. That's the problem. Like you're on Facebook, Instagram, and you're finding all these mold groups. My goodness, I can't believe how many mold groups, and there's like a new one showing up every day. There's some the architect from out east. I'd love to meet that gal. She does mold a lot abatement. I've done 1 million square feet of mold abatement. So I'd like to meet that woman one day. So ERVs, HRVs, I'm not an expert, not my field. Brett's got smarter people than me, but I need a system because we're building one, and I need a system. But you have to have a solution. You have to have a backup plan. Literally, an affordable house would normally have a 60,000 BTU furnace. Now they only need 6,000, maybe 12, maybe less. That's all that they need to have, depending upon what climate zone that you're in. And So this backup solution, what is that? Well, you need a dehumidification system that runs 24 hours a day that helps out your normalized system work. You need this other additional system because it's not designed for. If you live in a dry climate, you still create humidity because you're going to have an occupancy load. It's just how we work. So the result is an optimized system that's compact, all electric. I know I'm a natural gas guy because I was in the gas and oil industry before this, and I like to cook with gas. And I understand the reason to go to all electric. I got it. Okay. But you need to have a solar-ready, built-in, future-proof performance system. Is that ductless mini splits, ERV, HRV? We called them air-to-air exchangers back in the day. Heat pumps, all electric packages. I'd like somebody to come on Brett's system after me to back this up to say, okay, we can provide the system for that. If you can actually have low load houses and buildings, we have the system. Who are you? I'd like to know who you are. There's an introduction. Okay, net zero energy ready. So this is a stepping zone to net zero. A house that is built to such high energy efficiency standards that it could achieve net zero with a future addition of a renewable solar panel, wind generation, something that doesn't exist yet. So how close can you actually get to that performance level? I got to check my time. 11:32. I'm doing pretty good. Okay. Can a house be net zero without another source of energy? No, not technically. You can get close. So how close can you get? We've actually tried. And I'm sure that there's other people on here who have actually tried as well, but you got to have something. You got to give it some juice. And a net zero energy home must generate as much energy as it uses over an entire year. I got that. Okay. But how close can you actually get? How do you design the house? How do you design the building? If you designed it up front for solar, do you need to have all those outlets in the house? Do you need to have a 100 amp circuit? If there's somebody here from Washington State, I don't know if they still do, but for a while they required every house to have an electrical outlet for an electric car. Okay, that's a 70 amp service if I remember right. But we can make houses, if they're designed right and have a few switches on them, you could probably get by with a 30 amp service at the end of the day. Just don't run the microwave at the same time that your HVAC system runs. Come up with something. But do we really need to have a 100 or 200 amp circuit, or can we actually all sit down together in a room and figure it out? Okay, I'm opting for everybody sitting down. What would a system like this solve? High energy bills, slow construction times, fragmented trades, and labor shortages. Labor. Texas has lots of labor. We're losing labor left and right. I'm a finished carpenter. When I go out, when I retire, who's going to pick up what I do? Building envelope failures. I have seen probably more than most. Inconsistent quality, code compliance struggles. Good grief, building inspectors don't even know what some of us are doing or some other builders are doing, including Jake, Nick, and McCall. And there's others as well. Unaffordable housing and carbon emissions. I'm a big carbon emissions guy. Operational carbon reduction originally. Why does it matter? Lower upfront equipment costs. Okay. Yes, you're going to go from the traditional HVAC system, magic pack, whatever system you want to have, $15,000 metal ductwork. And now you're going to change it out for some, I don't know, off of Amazon, $500. I know you're not doing that, but you get the picture. You made it so energy efficient that you went from 60,000 BTUs to 6,000 BTUs. Well, that's a huge savings going to a ducted something system. But now you got to pick up the other system. You got the ERV, the HRV. If your state doesn't require it, but the 2021 energy codes do, you got to pick up that piece of the pie because you have to control moisture in the structure, or you're going to end up with a mold problem. So lots of builders are going to all plastic pipe, high velocity systems. I talked to a lot in a day. Obviously, I had to write a book to keep up to it, and more comfortable, stable indoor temperatures, probably a whole nother subject to talk about commercial buildings and people working next to each other. And I'm hot and he's cold. Or okay, next. Okay, here's your, I made up a form for you. You can copy and paste this out and claim it as your own. I purposely wrote marine wrong just to see if you'd catch it. And this is climate zones 0 to 7 and 8. Obviously, climate zone 8, you live in an igloo. And I wrote the wood framing U value for everybody, and then I did the math and I came up with your average R value on the right hand side. So I have the R value written there. So this is what you have to make. What's confusing to me is, why doesn't everybody have to design for the worst? Part of Texas is climate zone 0 and 1 and 2, but yet they've frozen. They've had frost in the ground 2 feet. They've had snow. They got snow in Florida. Well, if everybody designed for climate zone 8 and it didn't cost any more money, would you do it? Got you there. Okay, so here's that panel system in order to go pull that off. Now you have to figure out what this costs to go do this. In this is how I'm old school, certified energy auditor from 1979. Okay, so we had to do everything longhand. My first calculator had only one memory function. And so everything was done by hand. So this is how we calculated out. This happens to be a 12 by 9 panel. If I showed you how a corner looks or over a header, all of that, I'm not going to show them compared to anything else, but this literally has an R10 of outboard insulation and an R26 in the cavity on a 2x6 wall. My 2x6 stud 6.8. So on the bottom right in red, it gives you your average R value is 31.2. That's for the studs, bottom plate, top plate, and a header assembly in here, but literally went right through the whole dang thing. And I have your U value there. That's 0.032. Okay, pretty dang good, right? So on this, you only had to make for the worst climate zone 0.045 for a U value, or an average R value, and I think it's covered 22 point something. And so by the book, I have all these spread out in there. A way forward, solving the barriers and potentially solving for affordable housing at the same time. So when was panelization really invented? Okay, 1750. What's your guess? I'll say someplace in the 1750s. We started panelizing. We built the wall on the floor, and then we stood up the wall. Actually, we did balloon framing back then. So we literally stood up the whole thing, and we attached the floor to the side of the studs, and more than likely we had a dirt floor. 1750s, that's when panelization started. You didn't hardly ever did you stand up one stud at a time, and still today, unless you're in New Jersey, you don't put up one stud at a time in toenail, New Jersey. Okay, so do you panelize in a shop or do you panelize on the job? My longest wall that we ever stood up on the job, fully panelized, 56 feet long, and we had all the siding on it, windows in it, had the soffit and fascia already on. So when we stood it up, we just had to hand frame the roof from the top because it was 2.5 stories up. We didn't have enough ladders. I'm old. Okay, comparing on-site stick framing. Okay, I just tried to give you a bunch of math. I went to Home Depot. I bought up all the lumber to build this is a 16 by 9 wall. I started running all the math so everybody could see it. Okay, so I'm trying to control my 8-layer lasagna, or our 8-layer lasagna over on the left to an 8-layer lasagna on the right that has all 8 control layers, and how much does it cost? And so I just tried to give you a metric. Do not think that that's gospel, but it's a form to fill out for each and every one of you to go fill out to try to figure out every step of the way, how much does everything cost? So this is not gospel. Okay, Jake, McCall, and Nick, they can all talk as soon as I get done talking. If you want to ask them questions, ask them, fire away. I know that they build they just bid out net zero garages, barn dominiums. Oh man, 8-bedroom, 10-bath house. Okay. So how much can you solve for and save in building in 30 days? And the rest of this is going to go really fast. Okay, there's a crap ton of money to be saved if you can take half the time off or a third of the time off or 2 weeks off. You got to calculate how much you can save. And there's a whole lot of trickle down effect that goes into that to save money. Trade simplified installation. It's got to be a no-brainer. Literally, builders are allergic to change. I know that. I had the first insulated stud on the planet. I went out there 5 minutes. They said, we don't need you anymore. And they had the first wall built. Okay. But they sound like they're allergic to change. Faster, repeatable construction. That's a fact. You got to make it simple and easy and a deliverable, because otherwise you got all these subs coming back and back and back and back and back. Build to meet and exceed the energy codes. Well, if every wall was panelized, you don't have to wait for the energy code like this. You don't have to wait for the energy code to change. Why wait? Why don't you just deliver it? If you're a builder listening, just build the dang thing. I'm here to encourage every one of you. I am. I'm not. Pick any system you want. Just go do it. The right size mechanical systems. There's our panel system on the right over there. You can see the whole thing. That's a 2x6 buried outboard foam, buried inboard foam. We actually have on this sample was all plywood on the exterior, a water resistant barrier, a different brand right there. So anybody can use anything, LSL, LVL, any kind of anything. We're non-denominational. I don't know how best to say that, but okay, deliverable, scalable. You got it. I'm going to finish up. How do you build a house in 28 days? I'm going to say that we have we did sell a license to a gentleman, so I'm going to give him a shout out now, and I don't know if he's online, but there's a Superior Walls franchise that did buy a license, and they want to help finish the story. Okay, so here's your first under the first guy, the guy who built all the houses in 1977. I have his schedule. Okay, I was a grunt on the job, but I happen to know the guy for a long time. So I have his schedule: 1 to 2 days, excavate, pour. 1 to 2 days, day number 3 through 5, foundation, get your under slabs done, get all the stuff that you possibly get done. Day 6 and 7, we were actually framing the walls before they poured the slab in the basement. A lot of times they put walkways around the foundation so that they could start framing the walls. It was that fast. But if you have a truly deliverable system, like I know that there's other things out there like a Superior Walls, they set the foundation, footing in the foundation in a day, right? 2,600 square feet to 3,000 square feet, depending upon how complicated it is. They actually have a crane on the job in 3 hours. Well, you take a system like ours, and now you can set the wall, set the floor behind it because you want your thermal break through the rim. If it's a 2-story, build the wall higher and drop your wall, your next second floor inside the top plate. So you have a thermal break through your second floor and the main floor at the same time, and then set your roof. And Affordable Houses, he's already there with the crane. He's looking at setting the whole bloody thing all in 1 day. 1 day, setting the foundation, the floor, the wall, and the roofing system all in 1 day. The second day, they put the roof on it because the roof came all dried in anyway with a water resistant barrier already on it, ice and water shield or something. And the whole entire wall had 0 ACH through it because they hadn't cut the windows in yet. Because if you set a 40-foot wall, you want to pick it in the middle. You don't want it to arch. Okay, so there's a shout out to those people and all the other people who do that because they're part of the future. You want to get to 28 days, you're going to need some help. I know I've seen a lot. So this is the rest of the whole entire structure. You're going to get this whole entire thing. So I'm not going to go through it, but literally we had 28 days to finish these houses and they met every closing date. Every one. Why panelization works. You can read that. Questions. You can find me on thermalstuds.com. There's the book I wrote. It's all about this, and it's 260 pages. I make $6 a book because it's full of color. And but it's every single system and all the nightmares I've been through in 50 years. So build it better. Let's build a future. And I'm done.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.